Dear students, today we are discussing about uh, some properties of system reliability. So let P is equal to, this is a vector, P1, P2, etc. Pn. You know that P1 is the probability of, so reliability of first component, etc. Pn is the reliability of nth component. We have discussed in the last class. Now, what is h of p? Yeah, we had to prove h of p1 p2 extra pn is equal to pi into h of 1 I comma p plus 1 minus p into h of 0 I comma p. So this is the question we have to answer, or we have to prove. Okay, to prove this result, let us consider h of p is equal to expectation of phi of x. So what is that? Expectation of phi of x is, you know, phi of x can be written as, in the last class we have, in the, I think in the last chapter 1, we have denoted uh, phi of x as uh, okay. So we have substituted the expression for phi of x, we have discussed in the first chapter, like this. So we can take the expectation inside. Since we are assuming all the components are independent, we can take the expectation like this. Okay, that into 1 minus expectation of, okay, this is written like this. And what we have, we can, so this can be again represented as, instead of expectation of xi, we can put this as pi. Pi into expectation, this is nothing but h of, that we have discussed in the last class, I think, h of 1 I comma p, vector p. So instead of expectation, we can write it as qi, or 1 minus pi. Okay, so this is the 1 minus pi into, this one can be represented as h of 0 I comma p. Okay, so that we have to consider. So this is a this is actually the expression for system reliability in terms of component reliability. This is actually vector corresponding to component reliabilities. Okay, I think you got the idea of deriving this expression. So that is a result we have discussed in this lemma. Now we consider a theorem that we have to prove. Let h of p be the reliability function of a coherent structure. Coherent structure, then h of p is strictly increasing. So in this theorem, the behavior of the h of p function is to be discussed. So we have to prove that this h of p is increasing. Okay, how can we prove the nature of a function, whether it is increasing or decreasing? We have to take the partial derivative, we have to take the derivative and check whether this is positive or negative. If the first derivative is positive, we know that the function will be increasing. If the first derivative is negative, then the function will be decreasing. If the first derivative is 0, then the slope of the function will be parallel to x-axis, that is increasing as well as decreasing, or parallel to x-axis. So let us take the partial derivative of the function h of p. Take the partial derivative. There is no rho here, dou here. Yes, it is dou by dou pa. We are differentiating the function with respect to pa to check whether this function h of p is increasing or decreasing. So we are taking the partial derivative. Okay. What will be the answer? When we differentiate this with respect to pa, you know, this vector is this vector is not differentiable with respect to pa because it can be considered as a constant. So there is only pa term here, so we can differentiate with respect to pa. So the derivative of this first function will be just h of 1i comma p, and so we will write that. So if you differentiate this function with respect to pi, it will become just yeah, just put dou here. Okay, and in this case it will get, it will become 0, become 1, and okay. I think this is the derivative with respect to pi. Since this function is not having pi, it can be treated as constant. Okay. So we obtain this result, and we can simplify again. Okay. So just replace with the minus sign. Okay. So what is the result? H of 1i comma p minus h of 0i comma p. Okay. But you know that what is h of 1i comma p? Yeah, that will be again written here. So actually h of 1i comma p is nothing but expectation of phi of 1i comma p x, and what is h of 0i comma p? That is expectation of phi of 0 comma x. Okay, we have replaced with the expression of h of 1i comma p with the expectation of phi of 1i comma x, and h of 0i comma p that equal to expectation of phi of 0i comma x. Okay, but you know that we are considering the coherent system. Because the structure function will be having two properties. What is that? The components will be relevant. Each component will be relevant, and phi will be increasing. So we can just write like this. Sorry. We can replace like this, and you think that since phi is coherent, phi will be increasing. So the value of phi of 1i comma xi x will be greater than or equal to phi of 0i comma x. What is the reason? What is the reason? Phi is coherent. Phi is coherent means what is the meaning of coherency of a reliability system? Phi coherent. That implies phi is increasing. Okay. Phi increasing means what is the meaning of phi increasing? Yeah, in this context we can write like this. Phi increasing means be greater than or equal to, this will be greater than or equal to phi of 0 I comma x. So that is the uh, meaning of phi is increasing in this context. Okay, so we use that information, and you know that if expectation of x is greater than 0, 0 implies expectation phi of x equal to 0 implies phi of x equal to 0. So okay, implies and implied by. Okay, so if phi of x y next 1 of x 1 I comma x greater than or equal to phi of 0 I comma x, then surely this expectation will be greater than or equal to okay, greater than or equal to 0. Okay, anyway, now we consider another information. What is meant by component I is relevant? What is meant by relevancy? Phi is correlate means each component is relevant. That means what is the relevancy condition? Yeah, for at least one configuration, this will be not equal. For at least one configuration, 1 I comma x, phi of 1 I comma x not equal to phi of 0 I comma x. For at least one I comma x. Okay, for at least 1 I comma x, right? That is a relevancy condition. Okay, so we have used two conditions. First one is phi is coherent. Phi coherent means phi is increasing. That means phi of 1 I comma x greater than or equal to phi of 0 I comma x. That so you also you know that expectation of phi greater than 0 implies and implied by phi of greater than or equal to 0 almost surely. So dou h p by dou p is equal to expectation of phi of 1 I comma x minus phi of 0 I comma x will be greater than or equal to 0. That is condition number 1. Again, we have one more information, that is phi is coherent. That means each component is relevant. That means for at least one configuration 1 I comma h, 1 I comma x, phi of 1 I comma x not equal to phi of 0 I comma x. Relevant, such components are called relevant components. Okay. So what is when phi of 1 I comma x that when phi of 1 I comma x not equal to phi of 0 I comma x, then what will be, what is the possibility? What is the possibility? There is a positive probability. probability for positive probability. There is a chance, that is phi of 1 I comma x equal to 1 and phi of 0 I comma x equal to 0. So there is a chance, there is a positive probability. So what will be the difference? So what will be the difference? Then then dou h by dou h p dou h p by dou pi is equal to expectation of phi of x. So it will be 1. Okay. So what is the what is the expectation? 1 into probability of, what is that? Probability of this is equal to 1 comma and this is equal to 0. Okay, so that is an event plus 0 into probability of one, either both will be 1 or plus 0 into, because in this case difference will be 0, and one more case is there. What is that case? Yeah, both are 0. In this case also both will be 0. So this is the expectation. 1 into probability of phi of x equal to 1 into probability phi of x equal to 1 let us keep in the next. So that will be 1 into probability of phi of x equal to phi of 1 I comma x equal to 1 comma phi of 0 I comma x equal to 0. So the difference is 1 plus 0 into probability of phi of 1 I comma x equal to 1 comma phi of 0 I comma x plus 0 into probability of 1 I comma x equal to 0 into phi of x I comma. So there are 3 possibilities. So in this case we can remove the 0 terms. What happens? Yeah, it will become, this is actually dou h by dou pi. Okay, so we can put that expression here also. So what will be the result? Yeah, we can remove all these things because that is 0. We can remove this one also. Okay, this is a probability, positive probability. Okay, this is a positive probability. So we have two possibilities with increasing assumption. It is greater than or equal to 0. The coherency assumption, so increasing assumption, we have greater than or equal to, but using relevancy assumption we can say that it will be greater than only. There is no equality because this will be, there is a positive probability. Okay, that is the reason. So this can be question number 3. So what is the result? Greater than 0. So that means first derivative, partial derivative of h of p with respect to p is greater than 0. That means h of p is, increasing. Okay. when partial derivative is greater than 0, we can say that okay, h of p is increasing. That is our theorem. So what is the theorem? Yeah, you can see that let h of p the reliability function of a coordinate structure, then h of p is strictly increasing. Strictly increasing in the sense should be greater than 0. So the arguments are, we have explored their arguments, and you can see the proof here. Okay, so we obtain that h of p is increasing. So that is the result, that the reliability function h of p is increasing, always increasing for a coherent system. For a coherent system. Okay. I think you got the idea, and you can write it down, and you can study this concept. Okay, it is very important. My research is based on this idea, increasing concept or partial derivative concept. I will show you the research outputs in later class. Okay. Okay, thank you very much.